One application of exponential functions is compound interest. And here's your formula for compound interest. A equals P times 1 plus R over N to the NT. So this is considered an exponential function because of these variables in the exponent. And what all of these variables stand for, P is the principal, or the initial amount that you're putting into the account. R is the interest rate, and you always want to convert it to a decimal when you go to plug it into the formula. N is the number of times compounded per year. So if we're told it's compounded annually, N would be 1. Compounded monthly, N would be 12, and so on and so forth. And then again, we have the N in the exponent, and that's times T, which is the time in years. And then that gives us A, the ending amount, so how much we have in the account at the end of those T years. So we want to use the compound interest formula to approximate the final value of $3,300 at 3% compounded quarterly for 2 years. So I'm going to start by identifying all of my different variables. So the $3,300, that's the P, the principal. R is this 3%, but we want to convert it to a decimal, which would be 0.03. N, we're told this is compounded quarterly, which would be 4 times a year. And then T, the time in years, is 2. And then we just need to plug all of those values into the appropriate places in the formula. So A equals P is 3,300 times 1 plus R is 0.03 divided by N is 4 raised to the N is 4 times T is 2. And now I just need to plug all of that into my calculator, which if you're using the TI-30X IIS, what that's going to look like is 3,300 parentheses 1 plus 0.03 divided by 4, close parentheses, exponent button, and then I need to put my exponent in its own set of parentheses. So parentheses 4 times 2, close parentheses, equals. You can see we get a final amount of approximately $3,503, and to the nearest cent, 28 cents. So that's how much we have in this account at the end of the 2 years.